Hey everyone. I hope you're doing well. Yeah. So I think we have a record low lecture attendance of 81 to start, which no doubt is because a lot of your week threes, or for many, no doubt the weekend, or for many more, no doubt this morning, has been plagued with COMP1531. So I'm sure there's a lot of people right now who are sleeping and this and that. I would love your feedback on the due date submissions, by the way, because it's this thing again where I don't like them being due on Mondays, but also I don't want them due later in the week. So the only real alternative is to go to Friday, the week before, and I think that if I did that, you'd all eat me. So yeah. We do what we can with we can. We do what, you know what I mean. So the other thing is I'm sorry as well that I'd probably normally make the deadline like 2 p.m. or something, but the problem is that in my experience again, if you make the deadlines due like during lecture times, people don't go to lectures and then they don't watch lectures and cut, you know what I mean? So there's like a flow-on effect. We try and think about things more holistically than just like right in the moment. But these lectures on Monday kind of suck. I don't really like them because like it's like your assignment was due like 2 hours ago and we're like, hey, come here, let's learn together right now, which isn't particularly fun. So I'm sorry that these aren't like Monday night or Tuesday morning and you have a little bit of a break, but that's okay. Just before we start, I wanted to let you know that on Wednesday this week, I'm doing an AMA with CSESOC. I don't really know much about this, but for 2 hours, I'm on a video and students can ask me questions. I guess in a lot of ways, it's a little bit like a lecture, except there's no content to do. So if you want to tune into this, I think you just have to join the Discord. I feel like for other AMAs, there has been like YouTube live links and stuff, but I don't know. I'm not sure. Maybe CSC Soccer is sharing just the Discord link to get people to sign up to it. But CSC Discord, might as well sign up if you can. Maybe I'll just plug that for them. They're trying to start a community. This is your community, so it's a good thing to go sign up to that. And yeah, you can check that out. If there is some kind of YouTube live link, I'll try and update it here too. I don't want to send out a notice to everyone because like I don't really think, who gives a damn if I'm talking for 2 hours. So I'm not going to bug everyone with it. But yeah, if you want to come along and ask me any questions that we don't really have time for in the lecture, please come along. Easy. People have asked when was iteration 1 due? It was due at 10 a.m. And I think just to talk to iteration 1 for a short moment. So I know there's a handful of people either watching this now or watching this later who are like, oh my god, that was chaotic. And I guess the point I would probably make with iteration 1 is that if you knew what you were doing, if you knew how to function, or if you knew how to work with people who do or don't know how to function really well, then you probably don't need to be at university, right? So a big part of why you're here is to trip and to fall and to make mistakes and to figure things out, because it just takes time, right? Like getting on top of things is hard. Everything from like testing properly to testing and implementing in the right direction to like coordinating with team members to to actually getting things in on time. And it's like, I'm sure there's a bunch of groups here that thought on like Saturday they were like, oh, I kind of got this together, yeah, it's all right. Like Miguel's just said this, like we kind of got this together and like we'll just like plug it all in tomorrow, and then like Sunday and then Sunday afternoon, and you start plugging it in and the bricks start to fall off the building and you think, oh my god, and then it just doesn't work together. Because it's good, like I work in startup land, right? So like in the last 2 years has been my first experience in running a an actual production system, right? Like being in charge of that. And there's like learning in that too, you know, like the first times we do stuff, we would push code that would sometimes break things, that would cause people to not be able to use a product. And essentially it's like, it's the same thing. It's like they're all learning experiences you go through, right? To get your, to get yourself together. So it's like, okay, things came together quite late in iteration 1. That's why you're doing this course, so that you can like F up like that. But iteration 2, I'm sure that as a team, you won't be sitting around on a Friday being like, okay, we're all going to finish our parts and get it together, right? Like you'll be thinking more about how to avoid mistakes you've made in the past. Yep. So it's a good learning experience. There are going to be a handful of people here. Like, there's usually like a series of kind of groups. There's like the groups that everything just goes perfectly. There's those that get along but they struggle. Then there's the groups where things don't go well and the group's kind of chaotic, but it's a little bit because everyone is kind of not doing the right thing. You know, like person A thinks person B is not communicating and person B thinks person A. You know, and that's just part of learning how this works. And then there's like the kind of fourth type of group, which is the one where you have some genuinely good eggs in a group who've been dealt a bad hand with team members dropping or just legitimately lazy people or something like this. And it really is a small proportion. You know, somewhere in that like 5-ish% of groups typically are like that. And to those students, all I'd say is that I'm sorry that it's been a rough couple of weeks or a rough weekend for you, and that just always talk to your tutor and they will help even the scales as much as possible. The best thing you can do is communicate with your tutor throughout the term. That's the best thing you can do if you're in some like piles of crap right now. Because we'll do our absolute best to make sure that you still come out of this as if things were. Yeah, sorry. I think that's what I said in week 1. Our aim is to make sure that you come out with the same mark as per the kind of effort and capability that you put in, regardless of your group. Though, you know, we can't stop you having like stress. You know, like that's just some people are gonna have a more stressful term than others. That's the very nature of the group work. And I guess last thing I'd say is you know, there has been some discussion throughout the terms about you know, with 1531 is like delaying the starting of group work until week 5, because students can drop until the end of week 4, right? And some of you have experienced students dropping. I don't really want your feedback yet, but at the end of the term, if anyone remembers, and I'll ask you again, let me know if what your thoughts are about delaying group work for like 4 weeks. And I'll just tell you right now, so the benefit of doing that is that, you know, if we delay group work for 4 weeks, then naturally your groups are going to be a little bit more stable. It doesn't stop bad groups, it just stops groups kind of like with people dropping. The thing I don't like that genuinely, and this is why I'm curious to see what you think at the end of the course, because it takes time, is that I think we really need 10 weeks for you to actually fully function in a group. Like genuinely, and I've seen this before, it's like you've spent 3 weeks tumbling now, and then you'll spend another 3 weeks like slowly getting yourselves together, and then usually in the last 3 weeks, that last 3 weeks is really critical, where it's like, oh, okay, like we're really getting this now, we really understand what we're doing, you know, and it kind of all comes together, and it's that coming together part that I think is really critical that you won't get in like 6 weeks. So think about that. Talk to me at the end of the course, because I'd love the feedback. And I don't mean 3 iterations in 5 weeks. That's the other thing that would suck about a smaller project, is you just get less learning experience, because we'd have to shrink it down. Ironwork says, it seems unrealistic to have some people learning a new language and having to contribute to a group project. I don't really know what that means. I mean, the Python we ask you to write is actually quite simple. The project itself actually is very simple language-wise. The hard part about the project is the like the coordination of things. You know, like all that we focus on is pretty much like we're pretty much like, here's some data structures, here's some loops and if statements and functions, and these are all programming concepts you're familiar with. So in the later iterations, we get into more interesting things about you know, maybe timers and like web servers. Like we're learning new stuff today, and we're going to keep learning new stuff. So, you know, it's already kind of structured that way, right? Like there's a new language to learn, sure, but you already learn a programming language, and it's really quite common in your life that you will get put into situations at work or in research contexts where you just get told you're going to learn a new language as part of this. So, you know, there's a little bit of that, but, you know, we do make things pretty easy in the first few weeks. It doesn't feel easy, of course, but, you know, a lot of the difficulty is in the Git and the teamwork and the stuff like that. And in the understanding of the specification. We know you can all program. You're all smart people. Anyway, I've talked about this enough. Just wanted to have a little friendly chat at the start. Though one random question, Tovarish says, is front-end usually harder than back-end? I'll give you a quick answer to that one. So front-end is different because when you build something, when you build a user interface, you're building it for theoretically millions of people to use, right? So you got a ton of variances. They're all on different devices with different speeds and different capabilities. The server side, though, the back end of a system, like the one you're building for the project, is typically very focused, like it runs in one place, so you have a lot more control over it. So in that sense, it's easier because it's more predictable. And that's also why a lot of people prefer to work on the back end than the front end, because they like the predictability of it. It's a little bit like how some people like physics instead of biology, because they feel like physics is governed by these really hard rules that don't feel as variable. That being said, typically a lot more of the complexity exists on a back end, though that's a very broad statement and definitely not true for a lot of cases. Cool. Okay. What's the time? 18. Nah, we'll get into this. So, start of this week, data transfer. We're gonna have a quick chat about this. It seems like a really random topic, but it's actually one of these topics that you will use this lecture in some ways more than a number of other lectures for the rest of your life, even though it's actually quite easy, which is all about data transfer. And we talk about this before we get into web servers, which is the rest of today and tomorrow, because it's actually a critical part of how we work with building web servers, which is the next lecture. So data transfer. Let's have a think about a term first, which is standard interfaces, right? So in any field of engineering, we have things or designs built by different parties for different purposes, right? What's a good example? I mean, there's a slide with this, but it's like, here you go. I have a wall adapter here. Oopsie. This little plug, right? Now, this plug was built by a different person who made, you know, another kind of plug that I have sitting around, right? Like, there's like another plug here, right? These are two different plugs made by two different companies, but they have a common standard interface. And that standard interface is, you know, the prongs and the ground pin. And standard interfaces are how we connect systems together, right? Even though many people are building them. So some examples you have are like USB, bolt sizes, train tracks, you know, web addresses. Like, these are all standards that are kind of internationally decided upon, and then everyone works towards them. And the reason they're useful is because they allow completely different parties and completely different people to have a common way to interact or to, you know, understand the world in some way, right? Not all interfaces are perfect, you know. Sometimes you'll find like, you know, like USB is a good example, right? They'll like maybe upgrade it and downgrade it, or they'll have two different types of it. And, you know, and then you got weird ones. For anyone who cares, I think it's like train track gauge map. Here's a fun fact. Sorry. Here's a fun fact for you. Lots of different countries actually have very different like train track widths. So I was talking about like standard interfaces, and it's like train tracks are kind of the same everywhere, but they're also not. So like there are some standard interfaces that are super universal, you know, maybe like USB, right? Used everywhere in the world kind of thing. And then you have other ones like, you know, PowerPoint adapters, which might like vary a little bit. depending on the system. So sometimes you might have to be familiar with a few of these things, right? You might end up with, oh my God, you might end up with like a couple of these. You know, and as a fun example, it's like these are the different train track gauges throughout the world, right? So I don't really know a lot about trains, but, you know, I'm pretty sure this means that you can't go get a train from India and bring it over here. And maybe you can, I don't know. But the point is, like, standard interfaces are in a constant state of trying to prevent things like this. Now, in the world of computing, one way that we deal with standard interfaces everywhere, even if you haven't thought about it, we're dealing with it. But a really particular example of standard interfaces is what we call data interchange formats. And the reason data interchange formats exist is because, you know, when you want to send data from one place to another, you typically will need to think of some kind of universal way to send that, right? So like you're probably familiar with some ideas like this, such as .csv files, right? Like comma separated. What does the V stand for? What does the V stand for? Common separated values? Yep. You know, you're used to these kinds of standard interfaces. However, it's like, think about it. It's like if you have a Python program, right, and you have a dictionary, right, like your data store from iteration 1, and you want to send that to a like a C program, or, you know, a JavaScript program or a Java program to kind of like grab in that data, right? Like how do you exchange that data between that? And that's where these data interchange formats come in. Because they're common interfaces that allow people to send or store data in universal ways. And there are three we're going to talk about today, which is JSON, YAML, and XML. So we'll start with the main one. This is like the critical one. This is the one to get your head around. JSON, or the JavaScript object notation, which you don't need to worry about the word JavaScript here, is a standard. This is the actual standard, I'm pretty sure. You can go look at this online. There's probably like... not really sure how to use it. Text. Maybe if this isn't it, there'll be something like it. Docs. I don't even remember. Great. So these standards are written somewhere on the internet. I don't really read them, and pretty much all of you aren't going to read them. But the point of JSON was they were like, you know what? A lot of data is essentially a combination of lists, dictionaries, strings, and numerical values, and true and falses, right? It's basically just a bunch of that stuff. So let's figure out a standard format that everyone can work with that is capable of dealing with dictionaries, lists, non-numeric values, numeric values, and booleans and stuff. And thus we get to JSON. So when you look at this here, you probably see something that looks a lot like a Python dictionary, right? But I'm actually here representing something in JSON, funnily enough. And like when someone's like, what is JSON? Is it like a programming language or something? No, it's like a text file. It's literally just a text file. Like when I say like this is a JSON file, I mean, it's like you would just save this quite literally as a text file on your computer. Oh my God, just drag down. Okay, you know, so it's just a text file like that. What are the differences between how data is stored in this JSON file here compared to a Python dictionary, right? Like if this was Python and I was just like, you know, my var equals, and then I have a dictionary, and inside of that I'll do like locations. You know, like this looks a lot like Python. The main differences here though are that unlike in Python, white space is ignored. So in a JSON file, this is perfectly valid JSON, right? Because it's actually using the braces and other things in like a more C style format, where it's like using these symbols in the code rather than indentation to convey structure. The second thing is that you can't have trailing commas. You can't have trailing commas. So you know that in Python dictionaries, like when you make dictionaries or lists, we encourage you to put trailing commas at the end of things. You can't do that with JSON. That's not how the language is defined. Remember we talked about languages. So very similar, which is great, because if you understand how to write Python dictionaries and Python lists, you can actually just pretty much translate it to JSON, except indentation doesn't matter, which is easy, and then you can't have trailing commas. So you're pretty much just trying to remember not to have trailing commas. So that's the JSON structure, and this one represents a dictionary which contains one key, which is a list of dictionaries where each dictionary is has two keys, which is suburb and postcode, right? Miguel says, could you remove the new lines too in JSON? What do you mean by new lines? I'm not sure what you mean by new lines. But let's actually have a look at like reading and writing JSON. So I've got two files here, which is JSON. Some people call it JSON. JSON. It's kind of the same thing. JSON. Yeah, we'll get to that, Miguel. I think it's probably the I'll show you that in a sec. So let's actually have a look at it. I got this file here called JSON. And JSON, very simple. This is an example taken from realpython.com. We need to, before we worry about the import, we've defined a data structure here, right? And this is a very Python-like data structure. Dictionary with names, list of names where they're dictionaries with first and last. This works with tuples as well, I'm pretty sure, because they're just treated like lists, I'm pretty sure. So this is our data structure. This you already understand today. Where we're going to look at new things though, why all caps? It's actually a good question. Max says, why is data structure screaming? why is it in all caps? I think the reason for that is because as of week 4, when I wrote this, because it's always been in week 4, I think I started to try and pylint my files more, because after we introduced pylint, I thought, wouldn't it be great if we pylinted our files so that we're like consistent? And I won't lie, I don't think I've done that with everything. But that's why it's a capital, because that's what Pylint expects constants, i.e. variables that you define that are not modified. They expect that to be caps. So that's why it's caps. Okay, so we got our data structure here. Now I could print out this data structure pretty easily. I could go print data structure, and if I ran this and I was like Python JSON it, I would get that data structure. Great. But what I want to do instead is actually print it to a file as a JSON object. So the problem is that if, like, here's the thing. If I just like opened a file and I just printed my dictionary out to a file, like that's okay, but the problem is the dictionary could contain really weird things in it, like classes or functions or other kinds of objects. So JSON is a very simple kind of thing. Now, what's happening here with me opening the file? So first I have to import the JSON library, because that's the library I want to use to actually, do stuff with JSON. Now I'm going to open a file. Now this structure confuses some students. I could rewrite this whole block just to be clear as file equals open that, and then I could say if file do that. Then I think I could say file.close or something like that. Now, I know my screen's in the way, but we're not really going to use that line. So this makes sense to you, right? We're saying I'd like a file. I'll go get a file in Python, and it will be the value of me trying to open a file. And that file I'm trying to open is called export.json in this folder. And I give it a W character when I open it to say I would like to write to that file. So this is a standard way to open files in Python. File name, permissions you want to open it with. So I'm saying I want to open this file. It doesn't exist yet, that's okay. And I want to write to it, as in I want to be able to just like add text or overwrite it completely. So I create the JSON file. I check if that file opened or exists. And then what I'd like to do is, I'll get rid of that line for a second. I use json.dump. Now what json.dump does, right? So .dump is a member function of the JSON import. It takes a data structure in Python, and it takes a file descriptor. That's what that's called. I'm just going to call it a file. And it writes that data structure to that file. So json.dump will dump a data structure into a file. Yeah, exactly. So grabs it, dumps it in the file in a JSON format. and then we have to close the file. Because, you know, you open a file, you got to close the file, you know, you're like, well, I'm done with it. The thing, though, is that in Python, there's this alternative syntax which you've seen with PyTest, where you can actually kind of say this in a more concise way, where you're like, you know what, I'm going to set this value here to be the file variable, and then everything I do inside this with statement happens with this definition being true. There's some other benefits of that I don't really want to like drag on right now, but that's the kind of normal way that you'd open a file. With open this as file is really just another way of saying file is equal to open this, and then everything inside of that indent is what we're doing while that file is open. So it's a bit more concise. Now, this print line here is not necessary. This print line here is just for me to show you something. So we'll comment that out for now. I'm going to run this file, very simple, import JSON. Here's the data structure. So open this file as file, and then I would like to JSON dump the data structure to the file. So I run this again, Python 3 JSON it. A file just appeared in Sublime. I'm going to open that file and let me word wrap it, and let's have a look at what it looks like. So this is JSON. Now you notice that it doesn't have any white space. Well, it has a little bit of white space, but not much. And JSON is just made up of Python style structures like square braces for lists, square brackets for lists, braces for dictionaries, strings. Oh, the other thing, sorry, I forgot to mention one thing. I should probably update that. JSON also doesn't like single quotes. So single quotes bad. It wants everything to be double quotes. So Selena said in that open function we don't need to close the file. I'm pretty sure that's the case. Does with open close the file Python? I haven't looked this up in a long time. Here you go. If you don't use with, when does Python close the file? I'm going to assume that that's true, and I haven't forgotten that. I'll look it up later, but I'm pretty sure what happens is when you do with, it's kind of like saying to Python, can you destroy, like, once this indent has finished, like once I'm back down to this line here, can you please destroy everything that you defined in the with, right? So it like destroys everything it finds in the with, which is the file. So it actually, because of how Python is based on objects, it actually says to the file, hey, can you die? And file's like, all right, I know how to do that. And it's like, okay, how do I die? I close myself. Okay, I'm going to close myself, and then it closes. So that's why the with thing is useful too, because you don't need to do the close. That's why the pattern's pretty popular. Just looking, I saw a question before that was interesting. Oh yeah, did Python remove those trailing commas itself? Yes, it basically does, because Python is able to translate simple data structures to text, right? And that's why we get things like this. Now, JSON, when you dump it, can't export complex things, right? So let's say I have my names, my dictionary here with names in it, and then I say my JSON library is JSON. Now you can print this. You can print this fine, like I'll show you. I'm gonna print. Sorry, I'll print this. Print this here. Print data structure. Okay, prints fine. Look, the way Python prints this though is it prints the JSON library key here as module JSON from blah 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 on my computer, on the CSE computer. So Python, remember, understands everything to do with Python, but JSON, the markup, whatever you call it, is just comfortable with strings, numeric values, lists, and dictionaries. So watch what happens if I try and export this to a file. Probably going to get an error. The error says object of type module is not serializable. So basically what's happening here is when I try and turn this Python object, which includes like a whole library object, into JSON, it's like I have no idea how to turn JSON, the library, into a string or anything that is like JSON applicable. So that's kind of like, JSON is very simple, and it does convert it to text. There's a second function in Python, which isn't just json.dump, but it's actually json.dumps. It's not dumps. I mean, you could say dumps, but it's like dumps, dump string, dump s. And what it's really saying is dump the string. So like, don't dump it to a file. Dump means dump it to a file, but dump s means I want you to dump it to a string. So I could actually store that in a variable saying like jsonified equals json.dump, and then I could say print jsonified like that. And it will actually just print it out. So there's really two ways that you can convert a data structure, which is converting it into a string in JSON, and the other one is converting it to a string and dumping it to a file in one step, which is the line 25 here. Cool. So that's pretty straightforward, I hope. Then we have another file, which is unjson it. Now, unjson it is how we would reverse this process. And to reverse this process, right? Oh, well, my file's empty. Why is that? That's not good. Let's run it. Hey, okay, I got all my stuff in my file. So imagine that your friend has a program in like Java or C or something, and they send you a they send you this file. They're like, hey, here's some JSON that my C program outputted. Can you load it into your Python file? And you go, okay. So you import the JSON library. You open export.json, except this time you only want to read it. You could do W, because I think like write is read and write permissions, I think. Maybe I'm wrong. But you want to read it this time, which actually won't let you write to it. So if you try and write to this file here, like if you say json.dumps, or dump, and you try and write to file, and you try and write like A, B, C to it, it will fail. It'll give you an error. But what we're going to do instead is we're actually going to load JSON from a file. So I say json.load file. And what that does is that opens the file, it takes all the text out of it, and it tries to turn it from JSON, the simple format, to a like Python like library usage. And we store that in a variable here called data. And then we can print data. So, oops, that's the wrong file. Python 3, unjson it, and then we can actually get that data from the file. And you see, if I change this file, say I want to add another, you know, let's add something to the dictionary here, where I say we've also got ages, which is just a list of 1, 2, 3. You'll notice that when I when I load it from file, it actually will load all of that into the Python object as well. So very powerful. You'll also see that if I don't have valid JSON, like let's say I get rid of that first bracket, it'll crap its pants. It'll be like, whoa, I tried to JSON decode your file, but I got this random piece of extra data that I don't understand, so it just does not decode it. Yeah, so one thing to make clear is that a JSON file is just a text file. It's not a data file any more than a Word document is a data file. It's just text. It's a string. The JSON library in Python is what is the capability that allows you to convert from a string in the JSON format to like workable Python objects, like dictionaries and dictionaries and lists of dictionaries and stuff like that. So JSON's a string. Just because I labeled it .json, it doesn't make it special. It's just a string. It's just a text file, which is another benefit of JSON. Like you can't store a Python class or a Python function in a text file because it's not serializable. It's not able to be converted to simple types. So JSON is for simple types. So we're going to be talking about that a bit more in the next lecture. So we'll keep just rediscovering this. But I just want to quickly go through the last two types. The first one is YAML, which stands for YAML ain't markup language, which is a curious name. It's a popular modern interchange format because it's just more concise than JSON. You'll often find that in your adventures in life over the coming years, you're going to see a mixture of JSON and YAML. And YAML's a bit newer, right? And they're both completely interchangeable, right? They're both representing the same things: lists, dictionaries, you know, strings, numeric types, and stuff like that. It's just that YAML's doing it in a slightly more concise way. So I've just found this online converter, and I'm just going to paste this into the YAML side. Convert YAML to JSON. Oh, paste YAML data here. Got it. Convert YAML to JSON. Okay, great. So you can actually compare the difference here pretty easily. Now I'm not going into like the bones of like how this works. Like if you're curious, you can go and like poke around it. But you can kind of see here that, you know, they're defining locations as a list. And then because it's got many items, each item starts with a dash. And then there's like dictionaries inside of it. And each dictionary key is kind of just its own like key colon something until you get to the next list item. I actually think it's a little bit confusing to start. Like if you look at this and you're like, ugh, like that, I think that's kind of normal because the way they kind of express lists and dictionaries together is not as, I think, obvious. But it's very concise, right? Like you can see here, it's extremely concise. You don't need all these braces everywhere and stuff like that. And you're like, oh, well, you know, we don't need those braces in, you know, JSON. We'll just get rid of them all. It's like, yeah, but this isn't going to be any easier to read, right? So the point of YAML is to create something that's a little bit easier to understand. Now, indentation matters in YAML. In fact, they'll use indentation a lot. For instance, if I have a list of postcodes here, 2034, I think they might do it. What? Oh, I did it the wrong way. Oh, how do I oh, that's a shame. I was hoping to how do we do this? I think we go postcode and then we go like 2033, 2044 or something like that. Oh, no, it's just like, I don't know. I've forgotten already. Oh, yeah, okay. Yeah, there. It's a bit funny. So, where's the difference? Well, YAML's not really commonly used as a data interchange format in terms of like, it's not like you'll send someone a ton of data in a YAML file. Most of YAML is used as a common way to express configuration. So for instance, take your project or any other repo. You've probably noticed that there's actually a YAML file inside of your project, and this is YAML. This is what the pipelines use to figure out what the hell to do with your code when you push to master and stuff. So YAML is pretty useful as in configuration context mainly, which is why we like it. And then the last type, which is XML. XML is kind of the oldest type of data interchange format. You've probably heard the phrase, like you've probably seen that around somewhere, even if you don't know what it is. It's called Extensible Markup Language, and it's a lot like JSON in a way, very rigid, very structured. The main reason that it's not used as much these days is because it's very verbose. Like it, I'm one step ahead of myself. There's a lot of crap there just to get the message across, right? This is kind of the same data structure we described before. It's also harder to process and interpret, like the engines that have to churn through that string and text. It's just a more complex language to parse, as in read and interpret. And it's also just bigger. Like you need a lot more bytes. You need a lot more physical space in a file to actually store something. So there's a lot of downsides with it. Someone said, is XML used for HTML? No, it's not really used for HTML. It's literally a data interchange format. It's used where something like JSON or YAML might be used nowadays. You'll just see it around sometimes. Like I think I've seen it floating around my UNSW sometimes. But you know, you won't really interact with it much. It's important to understand this exists and what it is, because it exists. It's around, right? Like, what was like that thing that's like Windows operating system usage statistics? Legacy stuff is crazy. Windows. I want Windows. Windows operating system market share by 2017. Oh, this one's not very exciting. I remember reading this stat around how like there's some crazy number of computers out there that still run like pre-Windows 7 operating systems that are like don't need software updates and stuff. So there's a lot of legacy stuff floating around everywhere. So it's important to understand the past. Now, that's pretty much it on data transfer objects. We're going to jump on to, so that's pretty much it with data transfer objects.